Alright, here we are again, another quick little video on using the difference quotient to find a derivative and also find the slope of an equation of a line, a tangent line. So remember, the definition of the derivative is f as the limit as h goes to 0. Now you might see this as delta x in some other books and materials, but it's limit as h goes to 0 of f of x plus h minus f of x all over h. The function they want us to use this time is use the difference quotient to find the slope of the function, and then we'll apply that slope into writing the tangent line at that point. So, function is f of x equals the square root of x plus x minus 1. Again, some of the simple steps, we're going to substitute x plus h wherever there is an x in the function in the original equation, then subtract the original function from original function, substitute in the equation, so we're going to subtract it. There's our f of x, and then expand or simplify the expression so we get down to where we can take the limit as h goes to 0. Okay, so here we go. What we have is a pretty gnarly little function here, but that's okay. We got this, right? F of x plus h. So again, I put that in. Wherever there's an x, I drop that x plus h in there, and that brings me right here. Minus 1, all under the radical, minus an square root of x minus 1 all over h. Well, if you recall from doing limits before, this is a perfect opportunity to use the process where we are multiplying by the conjugate. So you notice that there's a minus here, so I'm going to multiply by the conjugate, so I'm going to put a positive sign. Now everything stays the same under the radical. We just change this sign here, and that way when we do our a times a and a squared minus b squared, we're creating a difference of two squares here essentially. Then we can get rid of a lot of stuff. Now, after we perform that, so this squared, that squared, this x minus 1 squared, everything comes out of the radical. We get x minus h minus 1 minus an x plus 1, and that positive came from after I square this piece here. So we're going to end up squaring both of these. Squared and squared, and when those come out of the squared, then we have to distribute this negative, so it'll be a negative x and then a positive 1. Okay, so we also have then in the denominator, don't forget your h, and you have the denominator of the square root of x plus h minus 1 plus the square root of x minus 1. All right, so what do we do then? We notice that this negative 1 here cancels with a positive 1, and this x cancels with that x, and so we are left with an h. So we come over here, we get, h over h times the quantity of x plus h minus 1 plus the square root of x minus 1. I think I said quantity, but it's the square root of x plus h minus 1 plus x minus 1 under the square root. Now, we notice that we can simplify these h's here, and that turns into 1, and then we get 1 over the square root of x plus h minus 1 plus x minus 1. And now we apply the limit. As the limit of h goes to 0, that's going to negate that. That's going to make that 0. And what's going to happen is I get x minus 1, square root of x minus 1, plus another square root of x minus 1. And when that happens, we get 1 over 2 times the square root of x minus 1. I challenge you, if you know anything about how to take the derivative of the original function, go ahead and do that, and I'll bet you come up with the same thing. All right, so the next maneuver is we need to write the equation of the tangent line. So it says right here, write the equation of the tangent line at 5, 2 in y equals mx plus b format. Well, our m, again, this is the equation of the slope at any point of our function, 1 over 2 square root of x minus 1. As soon as I put my 5 in, 1 over 2 times the square root of 5 minus 1. Square root of 5 minus 1 is 4. Square root of 4 is 2. So 1 times 2 times 2 is 1 over 4. So now our m is 1/4. And then we simply plug in our y and our x. 2 equals 1/4 times 5 plus b. We can get 5/4. We turn 2 into 8/4. 8/4 minus 5/4 is equal to b. And we get 3/4 is b. So the equation of our line is y equals 1/4 x plus 3/4. Now you might have to review that one a couple more times. Using the conjugate does create a little bit more algebra, but it's always good. You know, we learn a lot of algebra when we take a calculus class. So hope you enjoy it. Thanks. Talk to you soon.